So, what if the very same solar storms that can knock out our power grids could also somehow carry messages through time? I know, it sounds like something straight out of a sci-fi movie, but it's a question that's actually rooted in some of the most powerful physics in our entire solar system. In this explainer, we're going to break down this wild idea and see how it might just work.
Yeah, it's a huge question, right? And to even start to wrap our heads around it, we first have to understand the incredible power we're dealing with. So let's forget the Hollywood tropes for a minute, because this all starts with a very real and very violent event happening right in our own cosmic backyard.
Exactly. Before we can even think about bending time, we've got to understand the storm itself. What exactly is a geomagnetic storm, and what makes it so unbelievably powerful?
You can basically think of it as a giant solar tantrum. The sun burps out this massive cloud of charged particles. We call it a coronal mass ejection, or CME for short. When that cloud slams into Earth's magnetosphere, that's our planet's invisible magnetic shield, the impact is just immense. We're not talking about a gentle nudge here. This is a full-on collision that literally warps and supercharges the very space around our planet. Down here on the ground, the effects of that collision range from the absolutely beautiful, like stunning, intense auroras that can be seen all over the globe, to the seriously dangerous. We're talking power grid failures, satellite blackouts, the whole shebang. But for what we're talking about today, the most important effect is that last one on the list. The magnetosphere becomes a plasma-filled resonant cavity. Okay, what does that mean? Imagine ringing a bell the size of a planet. That's what's happening. The space around Earth is now humming, vibrating with trapped energy. And that vibration, that is the key to everything that follows. So how do we get from this chaotic, planet-sized energy storm to time travel? Well, this is where established science starts to get a little speculative, and we begin to explore what might just be possible right at the very edge of physics. During a big storm, our technology starts to act weird. Satellite clocks can drift out of sync, and GPS signals get all distorted. Now, it's really tempting to look at that and think, time shifts, but the reality is actually rooted in some mind-bending physics. The immense energy and the high-velocity particles from the storm actually create tiny relativistic effects, little distortions in space-time itself that mess with our sensitive instruments. So no, we're not seeing time travel, but we are witnessing a planet-sized physics experiment unfolding in real time.
Okay, so if straightforward time travel is out, what are the theorists imagining? Well, let's dive into 4 really fascinating thought experiments that try to harness the storm's chaos in some incredibly creative ways.
First up, you've got plasma mirrors. The idea is to use the super dense plasma from the storm to literally bounce a signal back in a way that creates a time-delayed echo. Then there's weave embedding, which is basically encoding a message directly into the magnetic waves of the storm, kind of like a message in a bottle tossed into a cosmic ocean. Things get even more exotic with relativistic loops, which theorizes using the storm's twisted magnetic fields to create tiny, temporary bubbles where time itself flows a little differently. And finally, the most straightforward idea, device triggers, which is simply using the storm's raw, incredible energy as a giant battery to power some other theoretical time machine.
But here's the thing. All of these cool ideas run into the exact same massive problem: control. A geomagnetic storm is pure, raw chaos. Trying to precisely manipulate it for a message is, as one source so perfectly put it, like trying to etch data on a lightning bolt. It's just the sheer unpredictability makes these methods practically impossible.
Right. So sending a message to the past, warning yourself not to eat that questionable street taco, is pretty much off the table. It violates causality, that fundamental rule of the universe that says cause has to come before effect. But what if we've been asking the wrong question this whole time? What if the goal isn't to send a message backwards, but to just delay one going forwards? And this brings us to what might be the most scientifically plausible concept of them all, the plasma echo capsule. The idea here isn't to break the laws of physics, but to use them in an incredibly clever way to create what is essentially a time-delayed message. So the core idea is to treat the storm not as a vehicle for time travel, but as a natural, temporary hard drive. The chaotic plasma becomes a kind of memory field that can grab a signal, hold on to it for a while, and then release it hours or maybe even days later. So you see, it's not time travel in the classic sense. It's more like time-delayed delivery, but on a planetary scale. The analogy for this is just perfect. Imagine you're standing at the edge of a deep canyon and you shout, The sound waves bounce around off the walls for a bit before you finally hear the echo come back. Well, in this case, your shout is a packet of data, and the canyon is Earth's entire magnetosphere, all juiced up by the storm. The echo just takes hours, not seconds, to return. So how would this actually work in practice? Let's walk through it. First, you need the trigger. A solar storm hits Earth, creating all those necessary resonant plasma structures we talked about. Second, the launch. We fire a coded signal up into a magnetic flux tube, which is like a natural pipeline in the magnetosphere. Third, embedding. The signal doesn't travel, it just becomes a trapped wave bouncing around inside the storm's energetic fields. And finally, the release. As the storm starts to die down, its structure weakens, and it spits the signal back out where it can be picked up by a receiver on Earth. Now, to make this idea really concrete, the source material imagines this near-future technology called the Aurora Array. Just picture a global network of transmitters and receivers built for one single purpose. When a massive solar storm hits and knocks out all other communications, the array would send critical encrypted messages by literally hiding them inside the storm itself. It would create a perfectly secure and perfectly time-delayed communication channel. So here's how a 36-hour message would travel. At hour 0, bam, the storm hits, and the array immediately launches its data packet. Now, for the next 35 hours, that data isn't really going anywhere. It's just stored, echoing, and bouncing around inside the magnetosphere's plasma. Then, at hour 36, as the storm finally subsides, the packet is released and caught by a receiver, say, down in Antarctica. To the person at that receiver, a message has just arrived, seemingly from the past. This table really just puts it all together perfectly. The energy source? Totally natural. It's the storm itself. The capsule holding the message? It's just an encoded wave of plasma. The medium it travels through? Our own planet's magnetosphere. But notice the two most important features here. The direction is forward only, which means no paradoxes, no breaking the laws of physics. And its realism, while, yeah, it's speculative, is grounded in physics we can actually observe and measure today. Which, leaves us with one final fascinating thought. This kind of technology is probably a long way off, but it's not pure fantasy. So if you could send one guaranteed, unhackable message 36 hours into the future, what would be important enough to say? What information would be so critical that it needed that journey? It's a pretty powerful question to think about.